All right, on this question, the directions say, determine whether Rolle's theorem can be applied to the function on the closed interval. If Rolle's theorem can be applied, find all values of C in the open interval AB such that f prime at C equals 0. If Rolle's theorem cannot be applied, explain why. So I wrote over here the statement of Rolle's theorem so that we could look at the conditions and the results. And Rolle's theorem says, let f be continuous on the closed interval AB and differentiable on the open interval AB. If f of A is equal to f of B, then there is at least one number C in AB such that the derivative equals 0, f prime at C equals 0. So let's take a look at the conditions of Rolle's theorem. The first condition is that f needs to be continuous on the closed interval AB. So our function f of x equals x squared minus 4 over x minus 1 is a rational function. So typically rational functions will have discontinuities. Let's just see where this has a discontinuity. So to find that discontinuity, we would set the denominator equal to 0 and solve. And we get x equals 1. So this rational function f of x will have a discontinuity at x equals 1. And the interval that we're working with is from -2 to 2. So if we think about that on the number line, -2 to 2 is here, and this is the interval that we're working with. And we have inside that interval 1, which would be about right here, we have a discontinuity. So our first condition of Rolle's theorem is not met. The function is not continuous on the interval from A to B, and so Rolle's theorem cannot be applied. Rolle's theorem cannot be applied since f is not continuous on the interval -2 to 2. So that stops us from continuing with the rest of the theorem. So the first condition is not met, then Rolle's theorem does not apply. The directions on this question say, determine whether Rolle's theorem can be applied to the function on the closed interval AB. If Rolle's theorem can be applied, find all values of C in the open interval AB such that f prime at C is equal to 0. If Rolle's theorem cannot be applied, explain why not. I have the statement of Rolle's theorem here. And Rolle's theorem says, let f be a continuous function on the closed interval AB and differentiable on the open interval AB. If f of A is equal to f of B, there is at least one number C in AB such that f prime at C equals 0. So let's see if the conditions of the theorem are met first. We need f to be a continuous function on the interval from A to B. So for our problem, we have our f of x, our function, is x squared minus 2x minus 3 over x plus 2, and our interval is the interval from -2 to 3. So this function is a rational function. I can find where the function is continuous by setting the denominator equal to 0, or actually I'm finding where it's not continuous because division by 0 is undefined. So I set the denominator equal to 0, and I find that x equals -2. So looking at the interval we're working with the interval from -1 to 3, and our function has a discontinuity, but that discontinuity is at -2, which is outside the interval. So our function f is continuous on the interval from -1 to 3. The next condition is that our function needs to be differentiable on the open interval from a to b. So to be differentiable, that means that this function can't have any sharp turns, corners, cusps in the graph. And since we have a rational function here, we're not going to have any corners or sharp turns or cusps in the graph. The corners typically come when you have an absolute value function. The cusps come when you have some radical functions. And it does not happen when you have a rational function. A rational function is when you have a polynomial in the numerator divided by a polynomial in the denominator. So we do have a function that is differentiable on the open interval from -1 to 3. So we have one more condition to meet for Rolle's theorem, and that is this statement here that f of a equals f of b. And this is that the y values at the endpoints need to be equal to each other. So I need to calculate f of -1 as well as f of 3 to see if those values are equal to each other. So f of -1 is -1 squared minus 2 times -1 minus 3 over -1 plus 2. That's 1 plus 2 minus 3 over 1. And that's 3 minus 3 over 1, and we get 0 over 1, which is 0. And let's calculate f of 3. 3 squared minus 2 times 3 minus 3 over 3 plus 2. That's 9 minus 6 minus 3 over 5. That's 0 over 5, which is 0. So the final condition of Rolle's theorem has been met, and that is that f, let me write it over here with the rest of the conditions. So the final condition is that f of -1 is equal to f of 3. So now that the conditions are met, I get to my conclusion. And the conclusion is that there is at least one value of c in AB such that f prime at c equals 0. The directions in our problem say to find all values of c in the interval such that f prime of c equals 0. So we want to find the value of c that is guaranteed by Rolle's theorem. So we want to find where the derivative is equal to 0. That's what it's asking in the directions of the problem, and that's also what the conclusion of the theorem is. So we're going to calculate the derivative of our function. Our function is f of x equals x squared minus 2x minus 3 over x plus 2. And we're going to calculate the derivative with the quotient rule. And then once we calculate the derivative, we'll set the derivative equal to 0, and we'll solve that equation to find that value of c. That value of c that's guaranteed by Rolle's theorem. So using the quotient rule, I would have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared The derivative of x squared is 2x. The derivative of minus 2x is minus 2. The derivative of negative 3 is 0. The derivative of x is 1. The derivative of 2 is 0. We have a little simplifying to do, so I'll multiply this out. That would give me 2x squared minus 2x plus 4x minus 4. I'll distribute this minus sign. That gives me minus x squared plus 2x plus 3 over x plus 2 squared. I can combine like terms, and that gives me x squared. I combined 2x squared minus x squared. I want to combine negative 2x, positive 4, that makes a positive 2, and another 2x, so I get a 4x. And I'll combine a negative 4 with a positive 3. That gives me a negative 1. All of this over x plus 2 squared. So I've calculated the derivative. So I now want to set the derivative equal to 0. And solve this equation to find the values of c. I have x squared plus 4x minus 1 over x plus 2 squared equals 0. I can multiply both sides by the denominator to clear the fractions. And that leaves me with the numerator of x squared plus 4x minus 1 equal to 0. This is a quadratic equation. You can try solving it by factoring, but I don't believe this factors. So I'm going to solve with the quadratic formula. For my quadratic formula, I need the coefficient a of 1, b of 4, and c of negative 1. My quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll substitute those coefficients into the quadratic formula, and I'll have negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 1 all over 2 times 1. Negative 4 plus or minus the square root of 16 plus 4 over 2. That's negative 4 plus or minus the square root of 20 over 2. And I have, I can factor 20 into 4 times 5. And the square root of 4 is 2. And I can also reduce this to be -2 plus or minus square root of 5. So I've got two potential values of c, -2 plus square root of 5 and -2 minus square root of 5. I want to type these values into my calculator because with Rolle's theorem, the value of c is guaranteed to be in between a and b. So it has to be in the interval. So I want to see if these values are in the interval. So -2 plus square root of 5 is 0.23, let's say 0.24. And -2 minus square root of 5, I believe, is going to be outside of the interval. That's -4.24. And our interval was given to be from -1 to 3. So our interval was -1 to 3. So this value of c here is on the interval, and this is the value of c that's guaranteed by the theorem. So c is equal to -2 plus the square root of 5. So the derivative at the value -2 plus square root of 5 is equal to 0. On this question, we want to determine whether the mean value theorem can be applied. And if it can be applied, we want to find the value of c guaranteed by the theorem. If the mean value theorem can't be applied, then we'll write not applicable in the blank. I wrote up here the conditions of the mean value theorem. The mean value theorem needs for your function to be continuous on the closed interval AB and differentiable on the open interval AB. If those conditions are met, then there exists a number c in the interval from a to b such that f prime at c is equal to f of a minus f of b. I think I said that backwards. F of b minus f of a over b minus a. So this symbolically will be true, but we need to know what those symbols mean. These symbols mean f prime at c is the slope of the tangent line, and f of b minus f of a over b minus a is the slope of the secant line. So by this statement being true that f prime at c is equal to f of b minus f of a over b minus a is saying that the slope of the tangent line is equal to the slope at the secant line for some value of c that is in the interval. So first let's decide if the conditions of this theorem are met. The function that we're dealing with in this problem is f of x equals x cubed, and we're dealing with the interval from -1 to 3. I'm going to write that a little bit larger. Our function is f of x equals x cubed, and our interval is -1 to 3. So the first condition is that our function needs to be continuous on the interval AB. Our function is f of x equals x cubed, which is a polynomial function, and polynomial functions don't have any discontinuities. So f is continuous on all real numbers, but since we're only interested in this interval, we'll just write from -1 to 3. Then the second condition is that our function needs to be differentiable on the open interval. And because this function is a polynomial function, it will not have any discontinuities. It will not have any places where the derivative is undefined. So it will be differentiable on the open interval from -1 to 3. So the conditions of the theorem have been met. So we are guaranteed to have this statement be true, where the derivative at some value of c is equal to the slope of the secant line at the endpoints. Remember that a and b are our endpoints. We want to find that value of c that is guaranteed by the theorem. So to find the value of c, I'm going to do this calculation over here. I'm starting with the side because I know the value of a and b. I know the value of my function, and so I'm able to work out all the details on this side right now. I'm not able to work out everything on the left side because I'm trying to find that value of c, and so I don't know it. So on the right-hand side, I'm going to work out f of b, that's f of 3. That would be 3 cubed, which is 27. And I want to work out f of -1. -1 cubed would be -1. Now calculate f of 3 minus f of 1, -1, over 3 minus -1. That's 27 minus -1 over 3 minus 3 plus 1. Minus a negative is plus. That's 27 plus 1 over 4. 28 over 4 is 7. So I've worked out the right-hand side. Now I'm going to start to work out the left-hand side. For the left-hand side, even though I don't know the value of c, the left-hand side involves the derivative. So I need to calculate the derivative of the function. So my function is f of x equals x cubed. The derivative will be 3x squared. So my statement is the derivative at some value of c is equal to f of b minus f of a over b minus a. We worked out the right-hand side to be 7. On the left-hand side, we've got our derivative. And I'm going to solve for x, and that will tell me the value of c. I'll divide by 3. That's x squared equals 7 over 3. I'll square root both sides. And that gives me x equals plus and minus square root of 7 over 3. So I've found potential values of c, but if you'll recall here, the number c that is guaranteed by the theorem will be in the interval from a to b. So I need to calculate these values and see if one or both of them are in the interval. So let's calculate the square root of 7 over 3. That's 1.5. So C equals square root 7 over 3 is 1.5, and then negative square root of 7 over 3 would be negative 1.5. And if we think about our interval is from negative 1 to 3. 1.5 would be in that interval. However, negative 1, oops, I just kind of drew that in the wrong spot. The 1.5 would be closer to the middle. And negative 1.5 would be outside of the interval. So the value of C that we got, that is guaranteed by the theorem, the mean value theorem, is square root of 7 over 3. Thank you for checking out my videos. Have a great day.